Today we're going to talk about our arc length and sector area. A sector area is a portion of a circle, and a good way to think about sector area would be a wedge of pi. So it's part of the pie, it's part of the circle. And so this orange sector here is going to be represented by this angle M, radius R, and so this angle here is also going to be that interior angle of M degrees. Anything we measure in a circle is going to be out of the whole area, so we need to know what portion. So we're going to have the whole circle represented by pi times radius squared, and that's the whole area. Unfortunately, when we're finding the area of a sector, we don't have the whole circle. So we have to have a fraction of the entire circle, and that's going to be represented by the number of degrees in the sector over 360. That decimal, or that portion, is going to give us a percent or a decimal or a fraction of what the whole circle is, and we're going to multiply that times the area of the entire circle. So let's look at the way this plays out in an example. If we're given sector MPN, and we've got 80 degrees, and we need to find the area of the sector, give the answers in terms of pi, etc., etc. We're going to have 80 degrees out of a possible 360. That's the portion of the circle that's actually being talked about. So it's this here. And we're going to multiply that times pi times 3 squared. And so I'm going to do a little bit of reduction on this fraction. 8 out of 36 is going to give us, we can reduce both by 4. So we have 2 over 9 times pi times 9. Well, and we can also see that this is going to cancel. So that's going to give us 2 pi. Units are in inches squared. So we reduced that down until we got to something we could actually use. It's not a matter of, once you know the formula, it's really just a matter of applying it and reducing those fractions. Okay? So for sector EFG, we're going to have something similar, except we have 120 degrees with a 6 centimeter radius. All right, segment of a circle. A region bounded by an arc and its chord, that's this green part here. Area of a segment, we're going to have, this is the part of the segment, so it's sector area minus triangle area. Okay, so it's going to be the sector area minus the triangle area. Because we're going to have the whole wedge minus this triangle, it's going to leave us with whatever's left over. So if I'm going to find the area of the segment ACB to the nearest hundredth, and I'm given this arc length, I'm going to start out with the sector area. So it's going to be 60 over 360 times pi 12 squared. So I'll have 1/6 So I'll have 144 over 6 pi. That's the area of my sector. Let me pull out my calc here. Okay, so I've got 144 divided by 6. So that's going to be 24 pi. That's the area of the sector. So I'm going to subtract from that the area of the triangle. Okay, so if I'm looking at the area of the triangle. So what I'm going to have is this, and I'm going to redraw here. So each of these is 12. And we remember when we're talking about the area of a polygon, I'm going to be talking about finding this area here. So this up here is going to be 30 because it's half, and this is also 30. So I'm going to need to do a little bit of trig ratios here. So I could do 1/2 apotemp times perimeter, but I really just want to find this base here. So I'm going to do this. I know that this is a 30, 60, 90. So if the hypotenuse is 12, and I know that the short leg here is going to be half of the hypotenuse, so this is going to be 6. It's going to be 6. So the base is going to be 12, so the area of the triangle is 1/2. Base is 12, and my height I don't have. But since I know the short leg, it's going to be 6 times square root 3, because that's special right triangle. So I just need to reorganize this. So I've got 6 times square root 3, 12 root 3 for the area of the triangle. So my answer to this part right here is going to be 24 pi minus 12 root 3. And if I plug that into my my bad. Should be 36 root 3. You guys are probably going, what is he talking about? Yeah, 6 times 6, not 12. Actually 36. So 24 pi, plug that into the calculator. I've got 24 pi minus 36 root 3. And that's going to give me a grand total of 13.04 inches squared. So a little bit of work there to figure out the area of that triangle, but once you find the area of the sector, subtract the area of the triangle, and then you're good to go. Let's talk about arc length. Arc length is the same kind of principle. Arc length is m degrees out of 360 times the circumference. Which is, recall, pi times diameter. So, same principle. A portion of the circle multiplied by the measurement that I want. Here's what I'm going to do. Find the arc length of CD, which is 90 degrees, and the radius is 10 feet. Here we go. 90 out of 360 times circumference. So if this is, that's the radius, so this is 10 feet, so it's pi times 20. So 1/4, because it's 9 out of 36, which is 1/4, times 20 pi. So that's going to be 5 pi for my answer, and that's going to be feet. 5 pi feet is the answer to that one. Okay, so the same principle, we're multiplying a portion of the whole circle times the measurement that I want. That's all there is to it, guys. You can try the second example, and we'll see you next time.